Good evening guys, this is Vijay and welcome to my channel of YouTube. Now I'm gonna have a short video of 30 minutes. It's a bit long, it's my first longest video, but I'll try to cover less than that within 20 minutes because I'm gonna explain you all the assignment questions which are compulsory, and without these questions you can't attempt an exam. You may attempt but you won't get good marks, so I don't want to waste the time. This is Vijay Sai alias Krish Balasu. I'm gonna start the video. So let's have a look about our PPT first. This is the unit 1 PPT. So in my previous video I have already explained you about the OSI model. In this video let's talk about the TCP IP and the differences between them. The TCP IP model looks like this. It's similar, but you can observe the differences between the OSI and TCP IP very easily. Before that, I'd like to explain this TCP IP model. This is a combination of both the models. So you'll observe it has all the layers like physical, data link, network, transport, session, presentation, application. I'd like to fast forward this video because I need to cover all the topics. I have very less time, only 30 minutes, so please focus on the video. I'm going a bit faster. I think that would be fine for you guys. So now these are the applications, these are the IP protocols. These are the protocols defined from host to network. There might be some mistakes, please excuse me, I'll correct them in my later videos. Please comment below. Coming to the TCP IP model, as I have explained, host to network, physical and data link layer, it consists of no specific control. Network layer has these entities. Transport layer consists of TCP, UDP and SCTP. Application layer, as you know, it's a combined session, presentation and application layers. This is the first part of unit 1. Coming to the second part of unit 1, we have several things, but I'd like to cover only the important questions now. So I'd like to explain you various functions of various layers, but I'm short in time, so I'm going to the next question. It's nothing but conversion of digital to analog. I have all the PPTs. If you need it, you can download it from the description, or I'll have a link for you. As you know, the second unit is data and signals. Now data is nothing but an digital. It can be a digital or analog. It refers to information which is continuous. So let's first deal about digital to digital conversion, as it is important than analog to digital. As in today's technology we only use digital. No one likes analog. No one has the time to watch the analog and waste the time. So coming to this, we have bitrate and the bit length. You can see these both diagrams and you can observe small differences between them. Now we have 3 conversion techniques in this. In digital to digital conversion, we have 3 techniques: line coding, block coding and scrambling. First we'll cover about line coding. Converting a string of ones and zeros. I like to make it much simpler, so let's have a look about the DC components. As you can read the PPT, there is no use of me reading it, so I'll explain it in a shorter manner. DC components: when voltage levels remain constant for longer periods of time, increase in low frequency of signal. Most signals do not support low frequencies, so we can remove these DC components as those are not essential. Once give a glance of this slide, once just have a quicker view because this is important for this topic. Okay, now let's move on. Let's move on to self-synchronization. Clocks and sender, including the receiver, must have the same bit interval to have a proper interaction. So let's talk about there in line coding also has three types: unipolar, polar and bipolar. Line coding is a bit lengthy subject, so this is the structure of line coding. You can see it has different topics. Don't worry about them, I'm gonna cover them in an easier manner. Now coming to unipolar, all signals are on sides of the time axis. As you can see the graph, you have amplitude and time. The formula is same. Now coming to polar NRZ, you'll understand easier by looking at the graph. These are the graphs for I and L. If you need a detailed explanation, you can watch me another video. The link is in the description. Now let's go to Manchester and differential Manchester. Coming to this Manchester, it combines both techniques. Voltage changes at the middle. These Manchesters are a bit important, so I'm gonna give a quick glance about them. Voltage changes at the middle of the signal in the Manchester, and it reduces DL components. Coming to differential Manchester, it's a combination of NRZI and RZ schema. What I have said is Manchester is of NRZ, L and RZ. This is I and RZ. RZ is common in both the Manchester, but the difference is Manchester has L, differential has I. Okay, I'll give you a shortcut. In differential you have I, right? So NRZ also has I. In Manchester you have L. Okay, you have I and L, only two things. So if you remember the differential is I, as the second letter is I, you will automatically know that Manchester is L. Okay, now we have the last technique in this topic. It's bipolar. Block coding, you have several things, but let's skip them because we are in a bit hurry. Let's go directly for scrambling. Scrambling is the best thing, best catchy. It does not increase bandwidth for synchronization and has no DC components. Okay, let's have a look at the graphs. You can see the voltage signal over here. Let's have a look at the graphs. These are both two graphs. We can observe the differences between the positive one and the negative one. You'll come to know about it very much easier. This is HDB3 scrambling technique. It's one of the good techniques. Now let's have a look about another type of technique, which is called analog to digital conversion. In this we have pulse code modulation and delta modulation. Coming to the first one, pulse code modulation, it has 3 steps: sampling, quantization, binary encoding. So these are the components of the pulse code modulation, which is nothing but PCM encoder. Sampling is of 3 methods: ideal, natural, flat top. These are the 3 graphs. Coming to the quantization, it has sampling results. You can note down the formula if you need it, or you can just memorize it. Coming to the encoding, codes to zones, binary codes can be assigned, number of bits also can be given to these. The next topic is delta modulation. We'll come to this thing. The schema sends only the difference between pulses. If pulse is lower in value, it results in negative value. That's because we use 0. Next let's skip these things. I'll explain these things later. I have already explained about topologies, so I'm not gonna cover topologies in this video. You can have a look at the topologies in another video. It's very simple, no need to explain about topologies. Let's skip all these. It's an half-an-hour session, so I don't wanna make it longer. Let's move on to third unit. You guys can check out my previous videos for a better understanding. And the third unit is completely about data link layer, as I have said earlier. So that's why I skipped my previous topics, because you guys can find it easier. In this chapter you have a number of protocols over here, but among all these things the important topics are noisy channel and the protocols. Stop and wait, sliding window protocol. Sliding window protocol is the most important of all the protocols, so let's have a look about it. It's a one-way protocol, so it uses the full duplex transmission method. I like to give you a better view, so let's have this view. You have the source and destination. First the acknowledgement is sent to the source to send the data, so the data is transmitted. Better idea is to use same circuit for both the directions, so that the data frames are mixed with the acknowledgement. Okay. The disadvantage is reverse channel is almost wasted, and it can be overcome using piggybacking. In piggybacking technique, we send the acknowledgement and the frame, but the source only sends the frame. And it also has a disadvantage, because it causes delay outgoing. Acknowledgements it might take a bit longer. So its rule is that sender waiting for a fixed number of milliseconds, and if a new packet arrives, acknowledgement is piggybacked. Otherwise, by the end of the time period, DLL just sends a separate acknowledgement frame. It waits for a certain amount of time and it sends the acknowledgement, and the sliding window protocol follows this thing. As you can see, we have three methods: 1-bit, go back and selective repeat. 1-bit sliding protocol is window size 1, stop and wait, must get acknowledgement before we can send our next frame. Both machines are sending and receiving. This is an algorithm. You have the C code for this 1-bit sliding window protocol. You can neglect it, because this is we are not having a practical exam. We'll come to it later. I'll explain you the code in detail. Now let's have a look about go backend. In go backend, receiver simply discards all the frames, sending no acknowledgements for discarded frames. This strategy corresponds to receive a window of size 1. Now let's have a look about the important points. Frames 0 and 1 correctly received and acknowledged. You can just go through this PPT and understand everything, so I'm gonna skip it. Now go back and protocol. I have covered everything. If there are any minor issues, I'll make a special video for each topic. You can have a detailed view about them. This go back and uses pipelining technique for efficiency transmission, so that the transmission will be efficient. You can note down the formulas of 2 power m and 2 power m minus 1 for the respective outputs you need. So this is the differences between them: sliding windows, timers, acknowledgement. You can see all of these things happen in go backend, and you can also see the size, the algorithm. You have different things. So these all comes under the first 3 units. These are the important topics which I have covered. So I don't want to make it a bit laggy for you guys, so I'm closing this video for right now. As it has been already 15 minutes, I'll do another video for 15 minutes. Thank you for watching. This is Vijay. Please subscribe my channel, give it a thumbs up, and you'll like it so much. And I'm gonna make my videos better using a board, or I'll use a new latest technology. And these are all the questions from first 3 units. Next I'll explain you about the later units. Now give it a thumbs up or like if you like it. Please comment in the below, and I need your valuable suggestions and any corrections to be made. I'll make it. I'll listen to anyone. So thank you for watching my video. Have a good day. Good night. Sweet dreams.